Here's a question for you. When you write a message to an AI assistant like ChatGPT or Claude, how does it actually decide what to say back to you? Like, how does it interpret what you're asking before it responds? And why is it able to respond in coherent sentences at all? Maybe most importantly, why can it repeat back information about the world or politics or math? And why can it also get seemingly simple things like that totally wrong? Many people seem to think that when you talk with AI assistants, you're talking with this kind of like super brain storing tons and tons of information collected from the internet. The shocking reality is actually way weirder and way more interesting. At their core, almost every AI assistant that you can talk with today is just frantically trying to predict the most likely next word that comes after what you've given it, based on all of the words before it. In other words, you're talking to a giant autocomplete engine with an extremely fancy hat on. If you stick with me for the rest of this video, I'm going to try and explain how that works on an intuitive level, because I think this is the single most important thing to understand about AI in the year 2026. If you really internalize what this means, it should change everything about how you approach and think about using AI. And it should also help explain both why they are becoming so wildly capable and also why they are fundamentally flawed as a technology in ways that we really need to design around and be cautious of. Hey folks, my name is Brian Hee-Sung Kim. If you stumbled into this video cold, I'm an education policy researcher, data scientist, and former public high school teacher who's been doing research with the technology underlying modern AI since about 2019 for my PhD program. And these days, I spend most of my time running workshops and trainings on how to use these AI tools responsibly and rigorously for nonprofits and universities across the country. Places like Stanford, University of Pennsylvania, Boston University, Vanderbilt, and many more. This video is part of a course I'm calling the Open Augments AI Academy, which is my attempt at sharing everything I've been teaching to those institutions across the country for free, forever, and for everyone. If you want to know more about what this course is all about, why I made it, and why I think I'm worth listening to on this subject, I would love for you to read the full course description page and also take a peek at the course introduction video first, which I will link in the description below. Today's lesson is the very first lesson of the whole course, and it's where I've started every single one of my workshops and coaching engagements so far, no matter who's in the room, total beginners, professional data scientists, everyone, because understanding how modern AI works at a fundamental level is the foundation that everything else gets built on. So, with that, let's get into it. I'm going to simplify the underlying math and mechanics a lot, maybe too much, honestly, but I promise you the general intuition here is all still worthwhile and accurate enough to be useful. So when we talk about most modern AI assistants like ChatGPT or Gemini or Claude and all of the rest, they're all based around something we call a large language model. To unpack that a bit, a language model is a special sort of computer program that we use to try and describe and simulate how we actually put words together in our everyday speech and writing. So if we give a language model the start of a sentence like, "My favorite food is ... its job is to try and finish that sentence in a sensical, valid way by filling in the blanks for us based on its understanding of human language and grammar and frequent examples of sentences like this that it's seen before. A good language model might fill in something like pizza or ice cream. They are both grammatically valid and also relatively sensible guesses based on people's general preferences. A bad language model, on the other hand, might instead say something dumb like, "My favorite food is tree," or "My favorite food is walked," or "My favorite food is oregano." Good language models understand grammar and context and have a strong grasp of general vocabulary and can generally fill in the blank more capably when we ask it to. But how do you actually teach a computer program how to write coherent sentences? Well, that's where the large part of large language models comes in. When we say something is a large language model, we basically mean that it's a language model that we built specifically by throwing a very large amount of text and writing together and essentially having a fancy mathematical and statistical program try to learn the rules of language, the meaning of words, and some general knowledge by studying the relationships between words in the example texts that it's been given. It learns by example, and we found that if we give this mathematical and statistical program enough examples, it actually starts to get really, really good at understanding language. Many of the advances of the past decade in this arena have come from pulling together every bit of text that we can find from the internet for this process, because more and higher quality example data produces smarter models. So we grab Wikipedia, we grab every newspaper article we can find, any digitized book or novel or movie script, grab whatever public social media posts you can find, scrape out the text of every website you find on the internet, and so on. You pull millions and millions of pages of examples for the large language model to learn from. We call that all the training data. And it can start to produce and write more and more complex sentences, paragraphs, essays, and more in sequence while remaining coherent and faithful to overarching meaning and structure as it goes. This is, I think, one of the craziest things that we've ever come up with as a species. To be able to teach a computer program how to speak a language with just like brute force math and statistics, giving it tons and tons of examples, it's wild. But to bring it back together and to reel it back in, almost every chatbot assistant that you can think of today is some version of a large language model, which means they are at their core just a tool that by reading millions and millions of pages of text has a really good idea of what word should come next in a sentence if you ask it. Now, to put that a little more bluntly and critically, the AI industry, and we as a society by extension, have been spending countless billions of dollars to make what is effectively the world's fanciest autocomplete engines that have ever existed. This is the core engine that is driving almost everything you see today in the AI hype era. If that gives you a little bit of pause, it should. And let me freak you out a little bit more before we actually get into why this might be surprisingly maybe more powerful and useful and reasonable a bet than it might initially sound on its face. So let's take a deep dive into how most of these large language models actually perform their autocomplete steps, because it gives us some really important intuition we'll need to hold on to. This is, again, very oversimplified and overgeneralized, but I think it gives some useful insight regardless. So step one, remember that a large language model is a computer program. And because it's a computer program, it really needs to think mostly in terms of numbers and math. That's its happy place. What it's going to do first then is take each of the words it's been provided and basically try to define each word's meaning in context as a set of numbers. It analyzes the word, what it already knows about that word, and how that word sits in the sentence in comparison to the other words. And then it tries to represent its interpretation of that word's meaning as basically a big set of numbers. You can think of this almost like a really complex set of GPS coordinates with like many separate latitudes and longitudes that help it triangulate its meaning in numbers. The large language model does this for each word it's provided, and then, to again really oversimplify it, it can start to think about a sort of numerical pattern and trend of the sentence. Where is this sentence going based on the words in the sentence so far? You can almost think of this like sort of like plotting out each word's GPS coordinates on a graph and then drawing a trend line or a best fit line to point to what words it thinks is going to come next. This is super wild and complex math in reality that I think is super cool. But again, I'll hold back. Not something we need to get to in more detail right now. Because these are rough trends, and because there isn't really one single right way to finish really any sentence out there, the model is actually going to surface a bunch of potential good answers that all make sense based on the mathematical trends it's seeing. So, for example, in this sentence, it might calculate that pizza and ice cream and cheese are all pretty likely next words here. In parallel, it's probably going to decide that answers like acorns or salt are all really bad and unlikely answers. So what does it do with this list of viable options? Well, almost every AI assistant out there now just kind of like rolls the dice and lets luck decide what actually comes next. So if I give this sentence to a large language model right now, it might give me pizza. And if I ask it tomorrow the same sentence, it might actually say ice cream. The day after that, it might say pizza again. And then next week, something totally different. This is something that we call non-determinism, or basically that it's not going to give you the same thing every time, even with the same setup and conditions. Really, really important phrase that I want you to internalize. Now, this kind of randomness is totally fine for something that doesn't really have a ground truth to it. There is no one right favorite food. And of course, the large language model can't know your preferences just kind of off the bat. So then what happens in a case where there actually is a right answer? What if we change the starter sentence to be something more like, the capital of New York State is ... Now, take a second to consider, based on what we've talked about so far, what do you think the large language model is going to do here? How do you think it's going to decide what the next words in this sentence are? Genuinely, I would pause the video and just take a second to think it out for yourself. Okay, so you might be surprised to learn that the process here remains exactly the same. It reads the sentence, it checks the trends, and then it tries to come up with a bunch of reasonable next words. Yeah, there is no special difference in the process here, even though there is a single correct answer of Albany. Now, it's probably going to have seen a lot of articles and sentences in its training data that correctly say Albany is the capital. But also, like a lot of people actually mistakenly think that New York City is the capital of New York State. And on top of that, many people call New York City the capital of the world. In the millions of websites and articles and social media posts the language model has seen, people have definitely gotten this wrong. And that might actually end up convincing the model that New York City is a reasonable answer here. So when it rolls the dice after coming up with those reasonable answers, it's probably still going to correctly respond with Albany more often than not. But because it's rolling the dice and because its training data has examples of wrong answers at least some of the time, it can still randomly end up with New York City, or even something totally out of left field like Washington, D.C. or Los Angeles. Those will be rare, but not impossible. People call these misses hallucinations, but the reality is that it's kind of always hallucinating even when it gets it right. The process is all the same. Better models trained on better data will get this right more often, but even the best ones can and will still get it wrong. There is no truth or fact filter built into this technology of large language models, and there are no automatic guardrails that stop it from saying the wrong answer at least some of the time. Its job as a large language model, by design, is just to come up with a reasonable guess of what word comes next, not come up with correct facts. And we have to always remember that those two things are not the same thing. Taking a pause. This is the most important thing that you can understand about large language models, and by extension, every AI assistant built on this technology today, which again is basically every single one you've heard of: Claude, Gemini, ChatGPT, the works. They all work this way. And this dice rolling element, this inability to guarantee factual correctness or truth, is by design. It's a feature, it's not a bug. Because actually what we found is that it's basically impossible to make a large language model truly understand language without also recognizing that there's very rarely ever one single right answer to what word comes next or how a sentence should be put together. They have tried to make language models using more rigid grammar rules and formal logic, facts, well-vetted references, and the fact of the matter is they just don't work as well. The randomness of large language models is a reflection of the flexibility inherent in communication and language. And unfortunately for us, the two can't be separated. So here we are in a world where AI doesn't actually by default understand or think about truth and facts. It's basically just as happy to spit out completely made up lies as long as they make grammatical sense. If you've heard people call AI slop machines, this is what they mean. And if you're anything like me, this sounds like a fundamental and fatal flaw in this technology, and calling it artificial intelligence might feel like a bit of a stretch at best and deeply misleading at worst. It would also probably seem to you, a reasonable person, that building billions and billions of dollars of infrastructure and investment on top of this very untrustworthy foundation is the pathway to a pretty bad time for all of us. Now, this is the part that's probably going to be really hard to swallow. Everything I've just said is true, and all of those concerns are valid. At the same time, it is also true that these AI assistants can be enormously valuable and powerful and useful with the right approaches and care. And actually, what I'd argue is that this dice rolling aspect, this like engine of autocomplete with a fancy hat on, is both modern AI's greatest flaw and greatest strength in one. They are two sides of the same coin. Now, how can that possibly be true? Well, hold the thought, because that's exactly where the next video will pick up. And so more on that in a second. Before you move on, I strongly encourage you to dive into the interactive examples and exercises that I've put together for this lesson at the Open Augments Context Gym website, which is also fully free forever. You can play around with a bunch of examples and demos that should give you a clearer sense and idea of how a basic large language model actually works and set you up nicely in advance of the next video. I'd also love to hear from you. Is this how you thought your AI assistants worked? Does this explain any weird or surprising conversations you've had with them so far? Drop your thoughts in the comments below. And if you found this video helpful, the best thing you can do is like this video and share it with a friend, family member, or coworker who could also use a helpful guide to this wild world of AI. So the idea of thinking about AI as autocomplete with an extremely fancy hat is going to keep coming back up through basically every lesson as its greatest flaw and its greatest strength. In the next lesson, we're going to talk about how to start exploiting the flexibility that this autocomplete functionality gives us. And by doing so, we can actually get large language models to do things that they were genuinely never designed to do to begin with, and to teach them topics or facts that they've literally never seen before. This is where things are going to start getting really interesting and hopefully really useful for your everyday interactions with AI. That next lesson of the Open Augments AI Academy lands next Wednesday. So subscribe here on YouTube by hitting the notification bell, or subscribe via email at the free Substack link below to make sure that you hear about it when it's live. In any case, again, I'm Brian Hee-Sung Kim. Thanks for being here, and I will see you in the next one.